Hello my friends, welcome back to this new tutorial finalizing that implementation. In the previous tutorial we gathered all the wine features in that input data list, and now let's just finish this. It's going to be super simple. First, we're going to get in the new variable our model name, which according to you we're going to get how? Well, it's going to be once again thanks to the event, because actually when Lambda will respond to that event of having this new wine for which we want to predict the quality, well, it will have to take at some point our saved model, right? That's the point here. We have our saved model ready to make predictions, and so we have to call it to use it to make the prediction of that new one here entered in the event. And so now we're going to use the event again to call our model because it is part of the event. And so I'm going to call our event again, add a pair of square brackets, and this time I'm not going to get one of the wine features, but I'm exactly going to get the name of our pre-trained model from our event dictionary. Because you see, event is a dictionary here. And in that dictionary you have the features, but you also have the model name. And the key to get the model name in that dictionary is model name. Alright, that's it. That will retrieve exactly the name of our pre-trained model. And now the next step is to define once again a temporary file path because, as you might expect, we're going to load our saved model to make the prediction. And since our model was stored into a file, remember, using the Pickle library, with that dump function? Well, once again, we're going to use Pickle here to load that model into another file. And so that's why we have to start here by defining a temporary file path so that then we can initialize a new S3 client object to download inside the model, after which we will load our pre-trained model from the file. Okay? So once again, we have to do this whole process starting by defining that temporary file path, which will be exactly the same thing as before, first in quotes /tmp/, and then we're going to add a plus and, of course, our model name. Okay, great. So that constructs this temporary file path using our model name, and now we can use the file to download first and then load our pre-trained model. And so that's where the S3 client object comes into play. Now we have to initialize it. And so once again, we're going to call it S3. It's a local variable, so it's totally fine to call it by the same name as before, which now you might know what to use, right? To initialize an S3 client object, it's going to be, of course, the Bodo3 library again, from which we call, of course, there you go, first suggestion again, the client function, okay? Which takes as argument what again? Well, same as before, exactly the same, in quote, it takes S3. Alright, so that just initializes an S3 client object using Bodo3 to interact with S3, right? Remember, it just opens the connection with S3 so that we can work with S3 in order to load our pre-trained model saved into that file. And so, well, speaking of loading it, well, first we have to download it. We have to download the model file from our S3 model bucket. And so to do so, well, we call our S3 client object, from which we call exactly the download underscore file function, which will take 3 arguments, basically the arguments that it needs to be able to find and download that file, which is first the model underscore bucket, there you go, name. Then the second one is the model underscore name. And then the third one, as you might guess, of course, are temporary file path, temp file path. And of course, this temp file path argument is not used to find the model, that will be the first 2 here, but it is used to tell the download file function where to save the model. Okay, so basically, this whole line of code here will download the model file from our model bucket and save it to our temporary file path. Okay, and so now that this is done, the next step is to finally load that model. And for this, once again, we will use Pickle, the Pickle library, but this time with the load function. Remember, when we serialize the model, we use the dump function, but here we're going to use the load function because we want to load our pre-trained model saved into that temporary file path. Alright, and so now let's finish this. Let's finally load our model and make our final prediction. So we're going to continue here with a with, and then, of course, open. And then in parentheses, first we enter our temporary file path because this is what contains at the moment our pre-trained model. And then remember here we have to add the format, which according to will be ReadBinary or ReadBinary. Well, here we don't want to save anything. We want to read the model, and therefore it's going to be, of course, ReadBinary, RB. Alright, so that we can indeed open our downloaded model file in ReadBinary mode, and then we add here as F, that's going to be the file from which we will load our pre-trained model using Pickle. And speaking of Pickle, well, here let's add a colon, and just below, that's exactly where Pickle comes into play, because Now we're going to finally load our model, which I'm going to introduce in a new local variable, which I'm going to call model, and which we will get by using the Pickle library, from which we call indeed that load function. And in the arguments of that load function, what do you have to input? Well, of course, you have to input the file that contains currently our pre-trained model, and not to confuse with the temp file path. It's actually this file, which is basically the destination of that temp file path. And so here in the load function, we have to input f, so that we load indeed our pre-trained model from this file f using the load function from the Pickle library. Alright, and now we're almost done. The last step is to first go outside of this with and to finally return our final prediction. Okay, so let's start with the simplest. First, of course, to get the prediction, we have to call our model, from which we have to call now the predict method. Of course, the predict method from scikit-learn, because our model is still that random forest regressor model built with scikit-learn and trained with scikit-learn. So we can call that predict method again. And now, inside the predict method, what are we going to input as arguments? Well, it's going to be this. Of course, all the wine features that we enter manually in the event of our Lambda function. And all these features here are actually contained in that input data list. And so there you go. That's exactly what we have to input in that predict method. But remember, in the predict method, the format expected is actually a 2D array, right? We saw that many times in machine learning level 2 or even machine learning level 1, and many times in machine learning A to Z. In the predict method, of course, the format is a 2D array, just as in the fit method, okay? Whether you're training your model or making some predictions with it, it's always going to be a 2D array. And therefore, since input data is actually a 1D list, a list in Python is of 1 dimension, well, we have to add an extra dimension around our input data. So here, I'm going to take input data, but in the predict method, I'm going to enter it in another pair of square brackets, so that indeed we get that extra dimension, so that this whole thing, with the pair of square brackets, is a 2D array. And that gives us the right format. Our input data is now well wrapped into a list that matched the expected input shape format of the predict method. But now then, outside of the predict method, we have to add a pair of square brackets and enter inside the index 0, because actually what we're only interested in here is the predicted wine quality rating. And since actually the predict method returns a list-like object containing several elements, well, we have to select only the first one of that element given by the index 0, which gives us exactly the prediction, the predicted wine quality rating from 1 to 10. Now, how about we also round the predicted wine quality rating, because indeed, if you notice in the dataset, all the wine quality ratings are actually integers with actually no decimal, but let's still keep just 1 decimal so that, we can get an even more accurate prediction. For example, if the prediction is 5.6, we will know at least that our wine is actually closer to a 6 than a 5. Okay, so we'll just keep 1 decimal, and to do so, we'll just call the round function here before the predict method called from our model. Alright, and the first argument of that round function is our whole prediction, and the second one, separated by a comma, will be the number of decimals we want to round the prediction to. Okay? And as we said, we want 1 decimal, and then there you go, we close the parenthesis. Okay, perfect. And finally, we'll do one last thing just for a format concern. It's actually better to return the final prediction as a string in the execution result, when we run our Lambda function with that Lambda handler. And so to do so, we're just going to add a final function here, which will be, of course, the str function, and which will take the whole thing as input. Okay, so that we make sure that our final prediction result is returned as a string. And perfect! Now, congratulations, we are actually completely done with the implementation of our pipeline. This is the final code. Congratulations for having implemented it until the end, and mostly congratulations for having implemented the whole code of our machine learning pipeline. Now the rest will be entirely done in our Lambda function, including the final tests and the destinations here, and of course that automation part thanks to the Lambda triggers. So I can't wait to do these final steps in Lambda in the next couple of tutorials, and until then, enjoy machine learning.
Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.